Welcome back to all. So now we are back from the break. So the afternoon session, first we will start with my talk. So I will discuss on POPs monitoring capacity in Kuwait Institute for Scientific Research and selected result of POPs monitoring studies. So for my presentation, I have Yes. So for my presentation, I have two parts. One is like POPs monitoring capacity in KISR. So when I am saying the POPs monitoring capacity in KISR, actually our center SCRC-KUWAIT is located in KISR, and we have various advanced and sophisticated instruments in the center. Unlike other countries, in the beginning, we also had a big challenge to handle these instruments. But in the latter, we got good training, and currently we have good expertise as well. Moreover, our center received ISO 17025 certificate recently, and we used to cover various POPs in different matrices, include air, sediment, soil, milk, blood, etc. So I will show you some of the instruments that we have, like for the sample preparation, we have FMS, and for the ASC 315 accelerated solvent extraction. Then we have FMS, pressurized liquid extraction. Then we have SPDX extractor system, dry vapor concentrated system, multi-vapor, then vial concentrator, then nitrogen vaporization. Then these are some of the instruments that we have, like for the dioxin, polychlorinated biphenyls, polybrominated diphenyl ethers, pesticides, pH. We have the Autospec premium high resolution gas chromatography, high resolution mass spectrometry. Dr. Carroll is handling this instrument, so he will have the next session. Then for the dioxin, polychlorinated biphenyls, polybrominated diphenyl ether, pesticides, and PAHs, we have 7,000 series of GC mass Agilent. Then for the polychlorinated biphenyls, polybrominated diphenyl ethers, pesticides, pH, we have the Agilent system with the series number of 5977A GC mass. Then for the pesticides and pH, we have Shimatsu 2010 plus GC mass. Then for the pharmaceutical and polar compounds, we have ultra performance liquid chromatography, that is tandem mass spectrometer. Then the instruments we go, first one is like the PowerPrep multi-column sample cleanup system. Actually, this instrument is designed as a high-speed sample processing workstation. It is designed to automate the extraction and the cleanup of toxic compounds such as dioxins, PCBs, pesticides, and polyaromatic hydrocarbons from environmental, biological, and food samples. It processes from 1 to 10 samples in less than an hour. Therefore, we can achieve high recoveries and excellent precision for all target compounds. Yeah. Then we have Dionex accelerated system AC350. So this Dionex AC350 accelerated solvent extractor system is a sequential extraction system capable of automated extraction of up to 24 samples. Then we have this automated solid phase extraction system, SPDX 4790 Horizon technology. And this is a fully automated SPE system designed to rapidly process environmental water sample using SPE for trace level analysis of organic chemical contaminants. Then we have pressurized solvent extractor. This traditional extraction technique uses large amount of solvent and require lengthy extraction periods to remove the analytes from the sample matrices. These extractions are typically conducted at low temperature and pressure conditions. And this is the 7,000 series of GC gas chromatography, tandem mass spectrometry, GC mass. And actually, GC is a separation technique for volatile or non-polar compounds. Tandem mass spectrometry is a detection technique that ionizes and fragments molecules. Both precursors and product ions are measured, which increase the specificity and the selectivity of this detection technique. Then we will move to the HRGC HRMS. Actually, it has a resolution of 10,000 for the mass spectrometer, and this method is quite costly, and it is used for the measurement of dioxins, PCBs, polybrominated diphenyl ethers, pesticides, and polyaromatic hydrocarbons. Then I will have a discussion of the monitoring of polybrominated diphenyl ethers in the Kuwait environment. So first, I will give a brief introduction of the polybrominated diphenyl ether. Actually, this is a class of chemicals that are added to certain manufactured products in order to reduce the chances that the products will catch on fire. Then these chemicals can get into the air, water, and soil during their manufacture. They can leak from products that contain them or escape when the products that contain them break down. They do not dissolve easily in water. They stick to particles and settle to the bottom of rivers or lakes. And some polybrominated diphenyl ethers can build up in certain fish and mammals when they eat contaminated food or water. Then how people are exposed to these polybrominated diphenyl ethers? So people can be exposed to these polybrominated diphenyl ethers by eating contaminated food, especially those with high fat content such as fatty fish. Then another source of exposure result from breathing contaminated air or swallowing contaminated dust. Then working in industry that makes these chemicals or that make repair or recycle products containing these chemical flame retardants can result in exposure. Then how PBD affect pupils' health? Human health effect from polybrominated diphenyl ethers at low environmental exposures are unknown. In animal studies, these chemicals have shown some effects on the thyroid and liver as well as on a brain development. And more research is needed to assess the human health effect of exposure to polybrominated diphenyl ethers. Then the type of polybrominated diphenyl ethers. Actually, now 3 different formulation of polybrominated diphenyl ethers are commercially available. That is penta, octa, and deca form of polybrominated diphenyl ethers. The penta product, it is mainly added or principally added to polyurethane forms that are used in the household furniture and also used in carpet, underlay and on bedding. The deca product is used primarily in textiles and denser plastics such as housings for a range of electrical products, particularly TV sets. Then the octa product, a mixture of different homologs, is used primarily in plastics. Now, environmental and health risk of polybrominated diphenyl ethers. For the reason of the environmental and health risk, the commercial pentabrominated diphenyl ether and commercial octabrominated diphenyl ether technical mixture, their production was stopped in 2004. The total former production of this commercial mixture was approximately 100,000 tons each. Then decabrominated diphenyl ethers listed in 2017 and it is still being produced and used. And a range of specific exemptions have been granted for this container, such as plastic in electrical and electronic equipments, certain vehicle parts, textiles, and insulation foam. Now, monitoring of polybrominated diphenyl ethers in houses. Actually, in Kuwait, we have monitored in 70 homes these polybrominated diphenyl ethers. And in interest, in all homes and offices investigated, polybrominated diphenyl ethers were detected with a pattern similar to the distribution in the commercial pentabrominated diphenyl ether formulation. And the ubiquitous distribution of this compound in indoor environment in Kuwait may be due to the volatilization of this chemical from foam. That is example from foam padded furniture, mattresses. And you can see that from the figure itself, you can see that there is lots of possible chances of this volatilization of this compound. Like you can see the sofa set, the chair, and from the electronic equipments like televisions, printers, computers, and other consumer products to which they are added as flame retardants. And you can see that from here itself, the children's, they are more prone to this type of contaminant because they used to be in the floor and they used to creep, crawl from the ground, and there will be a chance of more exposed than the adults. Now, polybrominated diphenyl ethers in house dust samples. Actually, house dust acts as a sink and a repository for semi-volatile organic compounds. The analysis of compounds in house dust, therefore, we can use it as a reliable indication of the extent of indoor contamination. Then non-dietary exposure to chemicals through inhalation and dust ingestion may therefore constitute an important exposure pathway for humans. Although estimates of dust ingestion vary widely, and as I said in the previous slide, children will be more prone than the adult because they have a tendency to crawl in the floor. So now this is the implication for the non-dietary exposure. This is the publication from Javao et al. And it's in 2006, and they have done the house dust as a source of human exposure to polybrominated diphenyl ethers in Kuwait. So they have found that non-dietary exposure occurs principally via inhalation and ingestion of the dust. Then they have find out the reported mean concentration at Kuwait house dust sample was 148 nanogram per gram, and it estimate that children and adults are exposed to 14.8 nanogram per day and 1.5 nanogram per day respectively on a daily basis from the dust ingestion. Then the tenfold difference in exposure estimates between children and adult in the study supports previous report that children are greater risk from pollutants. Now, the electrical and electronic equipments and waste containing electrical and electronic equipment containing polybrominated diphenyl ether. The major PBD used in electronic is commercial Deca BD, which I have told you already. It is listed in 2017, and cathodic ray tubing casings, which were largely produced some years ago before the use of flat screen, partly contain this commercial octabrominated diphenyl ether, which has meanwhile been phased out. And freezers and refrigerators normally do not contain this brominated flame retardants. Then the import and export status. Import statistics were assessed from 2010 to 2019 for televisions and computers, and every year about 1 million of these devices were imported in an average. And in total, about 55,426 tons of televisions and computers containing 19,286 tons of plastics have been imported during these 10 years. These electrical and electronic equipments include an estimated 55.4 tons of decabrominated diphenyl ethers and 7.3 tons of polybrominated diphenyl ethers listed in 2009. But during the last 10 years, only very few cathodic ray tubes were imported because it has stopped, means now the most of the televisions are coming like a flat screen. So it is less than 100 tons. And currently, the most waste containing electrical and electronic equipments have been sent to landfill in Kuwait. Now, this is the data for the polybrominated diphenyl ethers in homes and office, and this is conducted by Java et al. In 2006. And you can see that here, the office has more concentration than that of the homes. And in home, the congener number 47 was the most abundant congener, representing on an average of 51% of the total polybrominated diphenyl ether concentration measured. And the next one is like 99. So it represents about 28% of the sum of the 8 congeners of polybrominated diphenyl ethers. Then similarly in home, you can see that in the office as well, this brominated diphenyl ether 47 was the most abundant congener, representing on an average of 42% of the total polybrominated diphenyl ether concentration measured. Then similarly, the next most abundant was BD99, and it represents about 30% of the sum of the 8 congeners of polybrominated diphenyl ethers. Then the entry of this polybrominated diphenyl ether to the aquatic environment. First one is like direct deposition from the atmosphere, then runoff from the land, directly from industrial and wastewater treatment plant discharges. Then polybrominated diphenyl ethers in the marine sediment samples. So this also published in 2006 by Java et al. And the result showing like polybrominated diphenyl ethers were detected in all sediment sample at concentration ranging from 80 to 3,700 picogram per gram dry weight. Then the dominant congener at all sites was BDE 183, which typically constituting 60% of the measured sum of these 3 congeners of polybrominated diphenyl ethers, with lesser quantities of BDE 153, 7 to 10%, and 15 to 20% of BDE 154. And the average concentration at the least contaminated site is around 10 times lower than the site with maximum polybrominated diphenyl ether concentration. Now, entry of polybrominated diphenyl ether into the wastewater treatment. Actually, they have like a different source, maybe like point source discharged by industry from the atmosphere, then runoff from land following atmospheric deposition, then household domestic wastewater and industrial effluents, then addition at wastewater treatment works, then likelihood of there will be a chance of in situ formation. It will be formed from there only from the treatment process. So this one is like a monitoring of sludge sample, and this have like a congener specific and some of the polybrominated diphenyl ether concentration data for sludge sample collected from the 3 waste treatment plants over a like 6-month period time. And the mean and the range of these some of these brominated diphenyl ether concentration measured, like in the Jahara region, we have found like 52.5 nanogram per gram with the range of 5.7 to 169.5 nanogram per gram. And in the Riga region, it was like 144 nanogram per gram within the range of 32 to 296 nanogram per gram. And in the Haylam, it was like 377 nanogram per gram and within the range of 23 to 1,599 nanogram per gram. And BDE 209 was the dominant congener in all samples, contributing between 70% and 90% of the sum of this polybrominated diphenyl ether, with lesser quantities of BDE 99 around 6% and 3.3% of BDE 47 and 1% of BDE 100. With the BDs 28, 153, 154, and 183 accounting only 2% of the sum of these polybrominated diphenyl ethers measured in most samples. Then polybrominated diphenyl ethers in the soil sample. Polybrominated diphenyl ethers and other semi-volatile organic compounds primarily enter soil via wet and dry atmospheric deposition. And the another possible pathway through which these compounds penetrate soil is the application of sewage sludge to agriculture land. Then in Kuwait, sewage sludge from wastewater treatment plants are dumped in the desert, and this may constitute an important pathway for these compounds to the terrestrial environment. Then monitoring of soil sample. So concentration of polybrominated diphenyl ethers in surface soil sample collect. Actually, they have done a survey of 140-kilometer transect across the Kuwait in order to assess the role of like urban. So they want to show that urban center as the major source of these persistent organic pollutants to the surrounding environment. And some of these polybrominated diphenyl ether concentration actually varied by a factor of 250 times. That is the range from 289 to 80,078 picogram per gram. Then the container profile were dominated by, like as in the previous, like BDE 209, it was accounting around 93% of the polybrominated diphenyl ethers in the soil sample. And once you are looking the wind pattern in the Kuwait, and there will be a wind direction, northwest direction, that is the upwind, and to the southeast across the Kuwait city. The average concentration of this of polybrominated diphenyl ether in soil sample collected downwind of the Kuwait city were 1.5 times the average concentration collected upwind of the city. This finding lends support to the hypothesis that urban centers are source of pollutants to the surrounding area. Then they have done some like seasonal variation of atmospheric concentration of polybrominated diphenyl ethers in Kuwait. Atmospheric concentration, they have done like 1 year period to examine the seasonal variability and urban-rural concentration gradient. The annual mean and range of the sum of the polybrominated diphenyl ether concentration was like 32 and in the range of 3 to 208 picogram per meter cube at the remote site, and 57 and in the range of 0.3 to 445 picogram per meter cube at the urban site. So in the urban side, they didn't find any seasonal variation, but in the remote location, yes, they have found like significantly higher than winter median of like this PBD concentration. The major continuous detected in most samples analyzed were BDE 47, 99 and 100, which together constitute like 85 and 90% of the sum of the 5 continuous measured in the polybrominated diphenyl ether at the remote and urban site respectively. Then polybrominated diphenyl ether concentration in sediment from the northern Arabian Gulf. So superficial sediment samples like were obtained from 25 locations within the Kuwait Bay and outside the bay in the northwestern Arabian Gulf to assess the recent pollution in Kuwait. The mean and range in concentration of the sum of the 11 polybrominated diphenyl ethers in superficial sediment was like 0.164 and in the range of 0.06 to 0.44 picogram per gram dry weight. Then you can see that there is a trend of like the concentration started to increase the above background in the mid of 1950s and increased sharply to maximum in the late 1980s. Then concentration decreased thereafter until another pulse in concentration was observed around the early 2000, followed by a decrease in subsequent years. it is likely that the initial pulsing concentration recorded in sediment is related to input from the Gulf War of 1991. Then polybrominated diphenyl ether levels in collected from cars in Kuwait. Actually, the presence of polybrominated diphenyl ethers in cars is linked to their use of flame retardant in electronic items and instrument panels, high impact plastic, foam and fabrics of car seat. Actually, there was yesterday there was like a special session for this from Dr. Roland and Dr. Shedin. So they have explained like what are the possible source of these polybrominated diphenyl ethers in the cars. And polybrominated diphenyl ethers in dust sample collected from 19 randomly selected cars in normal use in Kuwait, and to assess human non-dietary ingestion exposure to these compounds. The concentration of the total target polybrominated diphenyl ethers, like they have done like 14 congeners of polybrominated diphenyl ethers, were ranged from 68 to 17,200 nanogram per gram. With the dominant congener of BDE 209, it is observed in all car examined with the concentration ranging from 52 to 16,100 nanogram per gram, on an average account for 77% of the sum of these 14 congeners of polybrominated diphenyl ethers measured. Then a comparative study of polybrominated diphenyl ethers in Kuwait Bay. Actually, this is recently done by Al-Shammari, and a broader geographic study including offshore sediment sample and those in Kuwait Bay showed a comparatively lower degree of polybrominated diphenyl ether contamination. And the mean concentration ranged from 0.1 to 0.5 nanogram per gram and had done 0.02 to 0.35 nanogram per gram respectively. When we are comparing with the global data, the recorded concentration of polybrominated diphenyl ethers for the marine ecosystem in Kuwait are small, with the values below the documented for the location in the Northern Europe, Japan, and China. Then another study that also done in recently, like Al-Shammari, polybrominated diphenyl ethers in the landfill of Kuwait. Waste containing polybrominated diphenyl ethers are largely disposed into the landfill in Kuwait. This I have already mentioned from my beginning slides. And polybrominated diphenyl ethers were detected around all the landfill at the levels between 10 and 200 nanogram per gram, with deca form of brominated diphenyl ethers as major congener. And the levels are comparable to those at other landfills in industrial and developing countries. Also, major congeners of commercial pentabrominated diphenyl ethers, in particular, BDE 47 was detected in all soil samples. So these are the like a brief introduction of the briefing of the polybrominated diphenyl ether study has done in the Kuwait. So that's all now. Thank you. Now I think the floor is open for the discussion. I think, Roland, you can have a discover, you can have the suggestion. I think because most of the study, you are aware about the most of the study that have done in the Kuwait. So yeah, please.
Yeah, I mean, one important information is that KISR can analyze PCBs and the dioxins, and that in Iraq you likely have PCB contaminated sites, dioxin contaminated sites, and also the pop pesticides you can analyze in soil. So that's one important message. And the second, I think, is that you need to combine the analytical capacity of KISR and a kind of knowledge of people like Baudewijn Fokke and the Tau company, having done for now a range of developing countries, including countries in the region, this assessment, because both is needed. You need the combination first of the assessment of your sites now, and one site you already have, to decide, I mean, what samples to take to understand what is the problem and what are the risk. And let's say from your side of the big pesticide storage site, it's already obvious. I think you need to take action, but also maybe in combination with somebody who is experienced in such site assessment, and then to decide if you need to take samples there, or if you know what is needed to be done. But I think that this would be now very, very important for Iraq as a next step. So that was my observation for these two presentations, or two parts of presentations.
And what is the possible chance of the transboundary movement of these type of compounds, because they are like sharing their like borders? So is it like significant?
What like, do you mean transport? I mean
a transboundary movement. Like because as we said, like we have like this type of compounds in the carpets, and we can use this type of compounds in the cars and all, means like these compounds. So there will be a chance of like moving from here to there like that. So is it significant amount will be there, or just like a small fraction?
Okay, but I mean that's another topic. I mean, the first thing what a country need to do is to reduce immediate risks. Yeah. And I mean, the other thing is, yes, we do an inventory, and we understand that the PBDEs might be imported and exported. But also when you look to the overall risk for the PBDEs for Iraq, this is much lower compared to the risk of PCBs and dioxins, which you have in human milk at levels above the tolerable daily intake, and for such sites like these pesticide storage sites, where it's clear that there is a high risk for the surrounding population, that this need to be your highest priority. And I know that UNEP at the moment with a PCB consultant is developing a project. I don't know for the pesticides, so maybe somebody from the Iraq team might know if there is also a project developed to further assess and mitigate for your pesticide side. So maybe somebody from Iraq side might know this and could do an intervention. And maybe Shireen, you can translate it into Arabic, if not everybody understands it. Also, the person could reply in Arabic, and Shireen could translate.
Yeah, doctor, thank you. I will explain in Arabic now.
Yeah.
بالنسبة طبعا احنا ابتدينا الموضوع النهاردة بتقييم وضع الملوثات العضوية الثابتة، وكان في محاضرة بصراحة يعني مؤثرة جدا، لأنها بتوصف وضع في غاية الخطورة. الوضع لا يحتمل الانتظار، ولا يعني مثلا نقول تدريب وركشوب، لا احنا نكون أسرع من كده. لأن انتوا دلوقتي تخيلوا ان المبيدات دي بتستمر في التربة لعشرات السنين. بالوضع اللي انتوا فيه دلوقتي وضع يعني كارثي، هو مش بالأمر السهل ولا بالأمر الهين. لما بنلاقي المبيدات بيقيسوها في المناطق القطبية أقصى شمال الكرة الأرضية بتنتقل، فما بال الناس المجاورين المناطق السكنية الآهلة بالسكان اللي هي indirect contact، ما فيش على بعد أمتار أو كيلومترات بسيطة جدا بتتعرض لكل المواد دي. وكمان مش بس التعرض البشري، انت عندك انتشار في كل مكونات البيئة، في الهواء، في التربة، في المية السطحية، في مية الشرب، في المية اللي تستخدم في ري المحاصيل الزراعية. فالوضع يعني لا يعني بصراحة صعب جدا. احنا في مصر ما وصلناش للمرحلة دي. يعني وصلنا لمرحلة اللي احنا عندنا obsolete pesticides وعايزين نتخلص منها، والحمد لله أخذنا خطوات في التخلص. ففي تجارب دولية اسمها تجارب التوأمة. يعني لما بتكون بلد عندها نفس المشكلة بتنقل وحلت المشكلة، بتنقل التجربة دي لدولة عندها المشكلة المماثلة. ف أنا بقترح زي ما دكتور رونالد يعني وضح ان انتم ممكن تستعينوا بالنقطة دي، ممكن تخاطبوا وزارة البيئة المصرية وتوضحوا لها المشكلة وتطلبوا التعاون التقني، حتى لو ما فيش تعاون اللي هي مادي أو كده، بحيث إن يوفر لكم خبراء من اللي يشتغلوا في نفس المشروع وينقل لكم نفس الخطوات اللي انتوا تقدروا تنفذوها. انتوا تقريبا عملتوا ايدنتيفيكيشن، يعني عملتوا مرحلة التعرف، حددتوا نوع الملوث، تقريبا قدرتوا الكميات حتى لو في موقع واحد. يعني ما بنقولش اللي احنا بننزل بتقولين على كل المواقع مرة واحدة، الموضوع ده بياخد سنين، بس نبتدي خطوة بالجزء اللي هو تم التعرف عليه وتم تقدير كمية المبيدات فيه. وعلى فكرة مصر بتقدم دعم لأي دولة يعني أي دولة بتتقدم وبتطلب دعم حتى لو على سبيل نقل الخبرة، فهي ما بتتأخرش. فأنا هحاول أن أنا أكون إن كونتاكت عندي بالفوكال بوينت، أشرح له الوضع، ولو في إمكانية إن هو يتواصل مع أحد من ممثلين الدولة عندكم في العراق بحيث نشوف إيه الخطوات اللي إحنا ممكن نعملها. بس طبعا على سبيل السرعة لأن الوضع لا يحتمل الانتظار. كمان في حاجة، انتوا يعني مرحلة الاناليسز يعني هو الشعور اللي انت هتلاقي الحاجة انت شايفها بعينيك، يعني بعينيك كده انت شايفها قدامك بقى. يعني الاناليسز اوكي شور اكيد هيقول لك بوزيتيف، الحاجة موجودة وكمان معدية الليمت، دي موجودة في كل الاوساط البيئية بتركيزات عالية جدا، يعني دي بالعين المجردة. يا ريت يكون في بروتوكول تعاون مع وزارة الصحة لرصد الحالات اللي هي زي ما بنقول الهيلث امباكت، اللي هو المردود الصحي او تأثر السكان بالمبيدات. اكيد ارتفاع شديد في معدلات الاورام والسرطانات وما الى ذلك من الامراض المرتبطة بالملوثات، يعني حاجات كتيرة هتلاقوها جينية، تشوهات خلقية، يعني في مشاهدات انتوا هتشوفوها من غير اناليسيس خالص. فيرجى الأخذ في الاعتبار اللي هو المشاهدات الهيلث امباكت وحالة السكان، ده برضك لازم يكون في التقييم. فعن نفسي هحاول ان انا اعمل مداخلة وإشارة إلى الموضوع الخاص بكم في الوزارة عندي، بالإضافة إنكم أنتوا كمان تعملوا كده بشكل رسمي، خطاب رسمي، وإحنا ما بنتأخرش عليكم وإن شاء الله خير، بس يرجى السرعة. وشكرا.
I think
I finished Dr. Yasser. You can for Dr.
please go ahead.
Yeah.
شكرا جزيلا دكتورة شيرين لهذا التوضيح. طبعا احنا مستعدين لأي تعاون، وأكيد مصر هي بلدنا الثاني يعني، فإن شاء الله يعني ستم مخاطبة الإدارات العليا لتنظيم مثل هكذا فعاليات مهمة. فيما يخص الموقع الصويرة، حقيقة احنا حاليا في طور نقاشات مبدئية مع اليونب ومع البنك الدولي في مقترحين لمشاريع اثنين حقيقة. المشروع الأول يتضمن تأهيل البيئي لمخازن الصويرة، ومشروع ثاني هو الجرد الشامل للمبيدات ومخازن المبيدات في عموم العراق. فهاي مشروعين حاليا احنا في طور المناقشات الأولية، لم ترقى بعد إلى الاتفاق، لكن هي في طور المناقشات الأولية. في أفكار أخرى مع اليو ان دي بي وبنحاول أن نطورها. واكيد احنا اي دعم بهذا المجال، يعني حضراتكم انتم شفتوا الوضع المأساوي. هاي هي عينة حقيقة، بعض المواقع هي يمكن اشد خطورة، خاصة عندنا في المناطق المحررة نسبة الدمار هائلة. فاكيد هناك يعني الوضع يمكن اكثر مأساوية من الوضع في مخازن الصويرة اللي هي منطقة آمنة نسبيا. أكرر شكري لحضرتك وللجميع لهذا التعاون. Thank you very much.
Dr. Hassan, I think he's available now.
Yes.
Yeah.
Yes, Yasir.
Yes, you can make a discussion, sir, if you need anything.
احنا طال عمرك دائما نقول الدول اللي تابعه المركز، لربما الدول التابعه المركز، الدول الغربي اسيا اكثر الدول لربما نشاطها ضعيف، ومشاركتها بالتمويل من قبل الجهات المانحه ومن قبل المنظمات الدوليه لربما هي الاكثر دول اخذت تمويل. اخذت تمويل. الدول اللي اخذت اكثر تمويل هي الاردن الدوله الوحيده اللي ربما اخذت اكثر تمويل، وياتي بعدها من الدول العربيه اعتقد مصر اللي اخذوا تمويل متعدد ومنح متعدده. اتمنى من الاخوه في العراق يعني يحرصون على موضوع ان بامكانهم عمل مشاريع هذه والحصول على تمويل. بالنسبه لنا كمركز اقليمي طبعا خبراتنا حابين ننقلها باستمرار الى الجهه العراقيه، ونتمنى من الاخوه العراقيين يكون على اتصال دائم معنا، واحنا نعين ونعاون ونتمنى التوفيق للجميع. وشاكر لكم يا اخوان.
أمير.
اوكي شكرا. ثانك يو. حقيقة هي واحدة من مخرجات النب أو الخطة الوطنية لتنفيذ اتفاقية ستوكهولم، هي الإظهار الواقع والصورة الحقيقية للمواد الكيميائية ضمن اتفاقية ستوكهولم في العراق. فهي واحدة من هذه النتائج أنه احنا أظهرنا أو ظهرت أنه موقع الصويرة أو البي سي بي ومواقع كثيرة، وحتى الدايوكسينات والفيورينات. فهذه واحدة من أهداف النب. أما بالنسبة للمنح والمشاريع فإن شاء الله مثل ما تعرف حضرتك دكتور حسن أنه العراق يعني حديث الانضمام لاتفاقية ستوكهولم، يعني بال2016 احنا صحيح كنا نعمل وننسق معاكم، لكن ما كان له حق. يعني حتى من كانت دكتورة لولو أتذكر بال2017 اجتمعنا ويا جيف في مؤتمر أطراف في جنيف وردنا الدعم، لكن هم يعني حقيقة ما كانوا متشجعين. قالوا المفروض العراق يصبح طرف بالاتفاقية حتى يستفاد من المشاريع أو الدعم المادي أو المشاريع اللي يمولها جيف أو غيرها من المنظمات. فإحنا ما دام هسه حاليا العراق أصبح طرفا بالاتفاقية ونفذنا إن شاء الله، يعني إحنا في الخطوات واللمسات الأخيرة من الانتهاء من النب، فإن شاء الله هي هذه بذرة وخطوة الأولى باتجاه فرص كثيرة وللتعاون والتنسيق مع المركز الإقليمي لاتفاقية ستوكهولم في الكويت، باعتباره احنا العراق جزء من الدول اللي المركز تحت مظلته، وبالإضافة إلى جيف وكثير من المنظمات يعني. فإن شاء الله القادم أفضل، وإن شاء الله المشاريع وأستاذ وليد اللي هو الرجل عمل على جرد المبيدات، وهو وفريقه، وأستاذ بيار هو فريقه، والبي سي بي وضعوا أكشن بلان أفتر نب، وهذه الأكشن بلان هي تغطي تقريبا يعني أكثر المشاريع ذات الأولوية بالنسبة للعراق. فإن شاء الله القادم أفضل إن شاء الله. وإذا أمكن أنه عندي سؤال لرولاند. رولاند, I have some question with you. Roland?
Yeah, Roland is there, I think. Roland? Roland?
Okay. I will ask. You can answer me, Mr. Yasar, because this about the BBDE compound.
Okay.
Okay. After make the inventory about the especially in the advised e-waste, electronic and electric devices, which it contain the POPs compound, and inventory and put it in the storage, use it the useful part, and use it the metals just like gold, silver. What we do with the other parts, just like the bodies of this device, as we know, it still contain BBDE or other compounds of the POPs. What we will do, it's put it in the landfill, or put it or dispose it by incineration, or what we can do.
Yeah, actually this is like a little bit complex things that like even after the use of these type of compound, like what we have to do in the next means after the inventory, that means we find out that we have this much of polybrominated diphenyl ether compound in this sector, maybe like in the electronic sector or inside the car or in the carpet, whatever it may be. So we have to follow the proper like recycling, proper whatever the techniques that we have to avoid all these type of emission of these type of flame retardants back to the environment, and we have to send this to the correspondent where we have these type of facilities to how to do the proper recycling or proper destruction of these type of compounds. Actually, during the regional meeting, I guess Dr. Roland has said some of the countries, they have the ability to do this recycling. So actually, this is the possible ways, I guess.
And as we know that use of the PBDE or flame retardant in the car stopped in 2017.
But still, but you have to make still the DACA form is like they have some exemption to
luxury and all the cars, some part, but in the electronic device, the new one, it's still contain this compound or not?
No, I mean for the new electronics, normally you do not have the PBDEs included. I mean, you have seen yesterday in the presentation that today, let's say, the production of PBDEs is very low. But today you have other halogenate aromatic brominated compounds. Yeah. So also there, you need to do an overall thinking about how to separate and what you want to recycle. And because the topic is complex, in another workshop which Yasser was referring to, I suggested to think on a regional approach to manage these kind of materials that you can learn from each other. I know, for example, that Arab Emirates have a quite good e-waste recycler. I do not know if he's active also in other countries in the region.
Yeah. Okay. Thank you.
Okay, Shireen. Yes,
اوكي. بالنسبة للاستفسار، احنا بنقول ان المادة دي موجودة في الالكترونيات لحد سنة 2004، فاحنا بنتكلم على السكند هاند، وحددنا امبارح الCRT كاثود راي تيوب اللي هي بتشتغل بالتقنية دي. يعني فأنا بوضح لحضرتك إن مش كلهم، يعني الفلات سكرين لا ما عندهاش مشكلة، المشكلة في الكاثود راي تيوب سواء كانت كمبيوتر أو مونيتور أو تي في جهاز تلفاز. المشكلة في الجزء البلاستيكي البوليمر، مش في الجزء المعدني ولا الإزاز ولا أي حاجة تانية. إحنا بنتكلم على البلاستيك بس لأن هو ده المعالج. في أي استفسار؟ يعني حضرتك عايز استفسار تاني؟
لا شكرا. هو اللي هو هدف سؤالي هذا، يعني احنا عملنا انفنتوري على الاي ويست او ما يسمى بالاجهزه الالكترونيه في العراق في مؤسسات الدوله والوزارات. في سؤالي هو هذا، انه هل هنالك مثلا الحديثه انه في سبيل انه يتم تصنيفها، انه هذه الاجهزه غير حاويه على البوبس وهذه اجهزه حاويه على البوبس، بالتالي نصنفها كهازارد ويست؟
ايوه، هو الاجابه ان انتهى استخدام الماده دي لحد سنه 2004. فمن سنه 2004 فما قبل تعتبر الاجهزه الالكترونيه التي تعمل بنظام الCRT كاثود راي تيوب تحتوي على ماده الديكا، ولكن في مشكلة إن هي not permitted for recycling until now، لأن الديكا فيها موجود بمحتوى مرتفع، فما زالت مشكلة قائمة إلى الوضع الحالي اللي احنا فيه دلوقتي. فممكن تعمل ريسايكلينج لأي جزء ما عدا الجزء البلاستيكي.
وما مصير الجزء البلاستيكي هذا؟
والله احنا دلوقتي لسه منتظرين، لأن يعني احنا not permitted to recycle it until now، فلسه هنستنى هنشوف ايه القرارات اللي هتتاخد في الموضوع ده.
يعني يتم خزنها بمخازن خاصة وتبقى يعني إلى أن نعرف مصير هذه.
أيوه.
أوكي شكرا.
عفوا.
شكرا جزيلا.
Okay, thank you for the wonderful discussion.